Welcome to Notes 9.4. Today we're going to be talking about geometric series. So it says the sum, so that's the key word to a series, is the sum of the terms of geometric sequence is known as a geometric series. So the series 2.5 plus 5 plus 10 plus 20 plus 40 corresponds to the sequence 2.5, 5, 10, 20, 40. The sum of the series is 77.5. So an infinite series, a1 plus a2 plus ... an, is said to converge if the sum gets closer and closer to real numbers as n increases. And then it's said to diverge if it does not converge. So if it doesn't keep coming closer and closer to a number. So I'll give you some examples of converging and diverging. So if I had 1 plus a half plus 1/4 plus 1/8, so I'm multiplying this each time by a half, so my ratio here is 1/2. The series will converge, and it converges, and it's going to get closer and closer to 2. So 1 plus a half plus a fourth plus a 16th, it's just going to keep getting closer and closer and closer and closer and closer to 2. So it converges to 2. Versus if I had 1 plus 2 plus 4 plus 8 plus ... This one diverges because it's not getting closer to a number. So since r is equal to 2, the sum increases. So the main thing you guys need to know here is if r is between 0 and 1, it's going to converge. It's going to get closer and closer to a number. If r is greater than 1, so like in this case, r is 2, this guy is going to diverge because it's just never going to approach anything. It's just going to get larger and larger and larger and larger forever and ever and ever. And of course, this is when I'm talking about an infinite series, one that goes on forever. Okay, if I have a set series, like let's say to the 11th term, yes, I can figure out what that equals because it ends. It's finite. It's not infinite. So that's what we're going to talk about here. So when a1 is the first term, r is the common ratio, and n is the number of terms, these are our different formulas. So the first one you guys need to know is the sum of the finite. So this one ends. This will be the equation that we will be using. The one right below it is the same thing. All they did is they just distributed this a1 to get this formula. So I just generally use this top one. And then the second case is if I have an infinite geometric series. So that's one that doesn't ever end. It will only converge, and this is what we talked about up there, if r is less than 1. So again, we're talking about a half, a third, a fourth, whatever the case is. And if that's the case, this is the formula we will be using. So we just need to know these formulas and when to use them. So we have finite geometric. So for finite, one that ends, maybe I say to the 30th term, we use this formula, and if I have an infinite that goes on forever and ever, we can use this formula only if r is less than 1. So it says an infinite geometric series when r is greater than or equal to 1 does not have a finite sum. The series is said to diverge. So it just keeps getting bigger and bigger and bigger and bigger. Okay, so what do you need to find? Or what do you need to find the sum of the first 8 terms in this series? So things we need a1, we need to know what r is, and we need to know what n is. So those are the different things I need, a1, r, and n. So we need a1. Remember, a1 represents your first term. We need to know what r is. R is our ratio. And n is the number of terms we'll have. So let's look at this one. Can we answer these questions? So do I know what A1 is? Do I know what the first term is? Yeah, it's 3. Do I know what the ratio is? 3, 6, 12, 24? Yes, it's 2. Everything's being multiplied by 2. And how many terms do we want? We want to find the first 8 terms. So number of terms is 8. So then we go ahead, plug into the finite because we're only doing the first 8. So we plug into that formula right there and we get our answer. So the sum of the first 8 is equal to A1, which is 3, over 1 minus r is 2, to the nth power, so to the 8th power, over 1 minus 2. So we're going to get 3, and we'll go ahead and do 1 minus 2 to the 8th power. We'll just use a calculator for that. So 1 minus 2 to the 8th power, which equals negative 255. So we get negative 255 over, and then we're going to get 1 minus 2 is negative 1. Negative divided by negative is going to give me a positive. So what we're ultimately doing is just 3 times 255, and 3 times 255 is 765. So the first 8 terms, the sum of the first 8 terms is 765. All right, so this one says, find the sum of the finite geometric series. Okay, so let's just talk about the things we need again. So for these problems, we need A1, we need R, and we need N. So I can clearly see A1 is 3. Again, I'm going 3, 6, 12, 24, so R is 2. But we don't know what term number this 1,536 is. So the first thing we're going to have to figure out is what term are we going to, so we can figure out our N. So how we're going to do that is we're going to write our rule, our explicit rule. So we're going to make a rule. So remember, that goes AN is equal to A1 times R to the n minus 1 power. So A1 is 3, R is 2 to the n minus 1 power. Okay, the second thing we're going to want to go ahead and do, and I'll go up here, so step 2. So now we'll plug in 1,536 into the formula so we can figure out what n is. So we're going to get 1,536 equals 3 to the 2 to the n minus 1 power. Okay, step 1, again, we're trying to isolate where n is, so we're going to divide each side by 3. So when I divide that by 3, we're going to get 512 is equal to the n minus 1 power. Okay, remember, to get something out of an exponent, the opposite, the inverse operation, is to change it to a log function. So we get log base 2 of my answer is equal to my exponent. Okay, so log base 2 of 512, we can go ahead and do that on a calculator by doing change base. So we can do log of 512 divided by log of 2, and we can see what we get. So we'll do log of 512 divided by my log of 2, and that's going to give me 9. So we get 9 is equal to n minus 1. And then solve for n, we'll add 1 to both sides. So we get 10 equals n. So now we know n is 10. And now that we know this, step 3, plug it into the sum formula. So S of 10 is equal to A1, which is 3, 1 minus my R to the nth power, to the 10th power, divided by 1 minus R. So we're going to get 3. 1 minus 2 to the 10th power, again using a calculator, is negative 1,023 over negative 1. Again, I have a negative divided by a negative, so that's going to become a positive. So we end up getting 3 times 1,023. And that's going to give me 3,069. So the sum of the first 10 of this series is 3,069. All right, let's look at B. B is a little easier because B we can clearly see how many terms we have here. So we need to know A1, which is negative 15. We need to know our ratio, so from negative 15 to positive 30 to negative 60, so that's negative 2. And then we need to know how many terms there are. So there are 1, 2, 3, 4, 5, 6 terms. So n is 6. Plug into the formula. So we get S of 6 is equal to A1, negative 15, 1 minus R, so that's 1 minus, and then let's use parentheses, negative 2 to the 6th power over 1 minus negative 2. Okay, here's a huge mistake you guys make. You're automatically going to go, oh, well, this is positive. This is not positive. You need to evaluate negative 2 to the 6th power, which will become positive, but then it's still a minus. So just be careful there. So we're going to get negative 15, and then we're going to get 1 minus, and then negative 2 to the 6th power is 64. So it's still 1 minus 64. And then the bottom will give us 1 minus minus 2, which is 3. I'm going to go ahead and simplify this. So that's going to give me a negative 5 right there. So I get negative 5 times negative 63. And that's positive 315. So the sum of those numbers right there would be 315. All right, let's look at this. So now this is in summation notation. Okay, so this means sum. This is saying starting at the first one, going to the 10th one. This is your rule, A1 times R to the n minus 1 power. So let's go ahead and write that down. So this is just A1 times R to the n minus 1 power. So I can still get all of my information off of here. A1 is 5. My R value is that negative 2. And my n, how many terms am I going from? So I'm going from 1 to 10. So from 1 to 10 is 10 terms. Okay, so we can figure this out still. So I get the sum of my first 10 terms is A1, 5, times 1 minus R, so 1 minus negative 2 to the nth power, 10th power, over 1 minus negative 2. So again, we're just plugging into formulas here. So I get 5. Again, be careful. So this is 1 minus and then negative 2 to the 10th power. So if we did this on a calculator, just so you guys can see this, we would do 1 minus and then do your parentheses. Negative 2 to the 10th power. And I get a negative number, which I should. So that's negative 1,023. So I get negative 1,023 over 3. All right, these ones aren't going to cancel out all nice, but that's okay. I think we can do 1,000. Yeah, we can divide 1,023 divided by 3. So we have 5. This is going to be a negative. This is how I do it. 3 goes into 1, can't. 3 goes into 10 how many times? So 3 goes into 10 3 times with a remainder of 1. So then I put a 1 right here. Then I go 3 goes into 12 how many times? So that's 4 times. 4 times with a remainder of 0. And then 3 goes into 3 1 time. So I get negative 341. Okay, and now we're going to multiply those two numbers together. So when I multiply those together, I'm going to get negative 1,705. So the sum of the first 10 would be negative 1,705. Okay, let's look at this one. This one we have to be a little bit careful about because this one didn't start with 0, or it didn't start with 1. So like this one started with 1. So from 1 to 10 is 10, but from 0 to 24 is actually 25 terms. So let's write ourselves a little caution. So caution, there's 25 terms from 0 to 24. So just be careful with that. Okay, but again, this is still my A1, this is my R to the nth. And that's why it's no longer n minus 1 power, because now n is starting with 0. So this is still 0. So my A0, so technically it's now A of 0, which is still the first one. So like still if I plug in 0 right here, right, 1/2 to the 0 power is 1, 3 times 1 is 3. So it's still going to be that first one in your sequence. So I guess we should call this A0. So A0 is equal to 3. My R's 1/2. And my N is, we're doing 25 terms, so 25. So we get S of 25 equals A1, which is 3, 1 minus my R, so minus 1/2 to the 25th power divided by 1 minus 1/2. Okay, that top one, we're going to end up getting approximations here. So we're going to have 3. So we're going to do 1 minus 1/2 to the 25th power. So calculator, 1 minus 1/2, using parentheses, to the 25th power is 0.999999, lots of 9s. So we'll just write down 0.9999. So that is approximately 0.99999. I think there was 7 9s, something like that, divided by my 0.5. Okay, using a calculator again. So we're going to go back to my calculator, take that number, my last number, divide it by 0.5. And then we're multiplying that number by 3. So it's going to round to approximately 6. So we're going to get S of 25 is approximately 6. All right, next page. We're going to skip number 5 and we're going to go to number 6. So I want to write the summation notation to find the sum of the first 6 terms of the geometric series 3, 15, 75, 375. Okay, so again, we're first going to find my rule. So remember the rule is AN equals A1 times R to the n minus 1 power. So my first one is 3, my R from 3 to 15, 15 to 75 is 5. So R is 5 to the n minus 1 power. So this is my rule. And we want to write the summation notation. So 2 summation notation. So summation notation is with that sigma. So we're going to start from 1, so n equals 1, and we're going for the first 6 terms. So we're going from the first term to the 6th term. And then you write your rule. I'm going to put it in brackets. 3 times 5 to the n minus 1. You don't necessarily need brackets. And then when we find the sum, that's where we're going to use our formula. So S of 6 is equal to A1, 3, minus, or 1 minus R, which is 5, to the n power, which is 6, 1 minus 5. So that's going to give me 3 times negative, and we'd have to do that in a calculator, so that's 15,624 divided by negative 4. Negative divided by negative is going to become a positive, and again, just using a calculator, we're going to get 11,718. So just check that you guys are able to get these on calculators, these same numbers. And that's how you would write a summation notation. So for summation notation, you need to write a rule first, and then you can put it into the summation notation. Number 7, write a summation notation and find the sum of the first 10 of the geometric series. So I want you guys to go ahead, pause the video, and see if you can write your own summation notation here. Okay, so the first thing you should have done is you should have written a rule. So my rule was an equals 2 times negative 1/2 to the n minus 1 power. I'm just going to point this out because I see kids do this all the time. People want to multiply these together. You cannot multiply these together because this one has an exponent. You can't combine them, but I see students do it every year, so do not combine those. Okay, for step 2, you should have done your summation notation. So summation notation, you should have had your sigma. Should have started at 1, n equals 1, and we're doing the first 10 terms, so from 1 to 10. And then we would write our rule, so 2 to the negative 1/2 to the n minus 1 power. You could have brackets, don't have to have brackets, whatever the case. 3, find the sum. So we do S of 10 equals 2 times 1 minus negative 1/2, put it in parentheses, to the 10th power, over 1 minus negative 1/2. Okay, for this one, you probably were freaking out because you have fractions, but you guys can do it. So we would have 2 times 1 minus 1 over 1,024. Okay, divided by, and then 1 plus 1/2 would give me 3/2. Okay, the next thing I would want to do is get a common denominator for my numerator so I can combine these. My common denominator would be 124. So when I combine those, I'm going to go this direction so I don't run out of room. I'm going to get 2. And then we're going to have, the 1 is going to become 1,024 over 1,024. So I'm going to do 1,024 minus 1. So I just got a common denominator. So I got 1,024 over 1,024 is the 1. And then this one is negative 1 over 1,024, which is right here. Divided by 3/2. Okay, we know how to divide fractions, keep, change, flip. So, and I can simplify this, right? So simplifying this would be 1,023. So now I'm going to get 2 times 1,023 over 1,024. Change the sign, flip the denominator, so I get 2/3. Let's start simplifying where we can. So I can simplify by 4, right? I think by 4. By 3. Let's see. So these can definitely simplify. And if we did Well, I could do this. The 2 and the 1024, those will definitely cross cancel. So this becomes a 1, and this becomes 512. The 3 and the 123 will simplify, so that becomes 341. That becomes 1. And I can still do this 2 with the 512, so that's 256. So when it's all said and done, after I've simplified, I have 341 left in the numerator, and in the denominator I have 256. So that would be my sum. All right, so now we're going to talk about infinite ones. So remember, for an infinite one, and I know this is infinite because it goes ... which means it goes on forever. So with this, the first thing you need to do is you need to check your R value. So with infinite, check that. And remember, the absolute value of R must be less than 1. Okay, if it's greater than 1, it diverges, and we can't analyze it. So let's go ahead and look at this. Let's find the ratio. So the easiest way to see this ratio is look at your numerators and see what they're multiplying by. So to get from 1 to 3, 3 to 9, I'm multiplying the numerator by 3. To get my denominator, I'm multiplying my denominator by 2. So my R value is 3 over 2, because the top's being multiplied by 3, the bottom is being multiplied by 2. So my ratio that I'm multiplying by is 3/2. Is 3/2 less than 1? No. So since it's not less than 1, R is greater than 1, this series diverges. And you just can't analyze it. You can't find a sum. Okay, looking at this guy. So again, we're going to check our R value first. So the numerator is just staying the same. I can see I'm going positive, negative, so it's a negative R I'm multiplying by. 1 to get to 1 to get to 1, that's just 1. And then 3 to 9 to 27 to 81, that's 3. So I am multiplying by -1/3. R is in fact less than 1, so it converges, which means you're able to analyze it. So this is when we use the formula S is equal to A1 over 1 minus R. So we're going to get A1 is 1/3 over 1 minus R. Okay, this will end up becoming a plus. So we're going to get 1/3 divided by 1 plus 1/3 would be 4/3. And then you guys know how to keep, change, flip. Keep the numerator, change the sign, flip the denominator. So these are going to simplify, and we get this equal to 1/4. So this will converge, and this will just keep getting closer and closer and closer and closer to 1/4. All right, and the last one. If the series converges, you can use a calculator. We don't need a calculator. So this is infinite still, because it tells me from 1 to infinity. So this is still infinite. So you guys need to check your R value. Okay, so this one's a little bit weird looking, right? So this just has 2/3 to the n power. That's the rule. Well, 2/3 is still your R, because whatever is to the power is your R value. So R is equal to 2/3, and 2/3 is in fact less than 1, so it converges. So we can evaluate it. Okay, so we're going to get my sum is equal to A1. Okay, A1, we don't know, so we're just going to plug in a 1 right here. So I get 2/3 to the first power is 2/3, so A1 is 2/3 over 1 minus my r, and 1 minus my r is 1 minus 2/3. So we're going to end up getting 2/3 over 1/3. Again, we'll do our whole cube change flip, so 2/3 times 3 over 1. My 3's will cancel, so this will converge to 2. And that's going to go ahead and conclude these notes. So in sum, you guys need to know these two formulas. And one is for finite, so it stops, and one's for an infinite. All right, that concludes our notes. Have a great day, guys.